A question that's really important to all social mammals, and it's certainly important to humans, is when it's appropriate to punish. And we see that there are structures for punishment of violators in chimpanzee societies and baboon societies. By violators, I mean those who assault others or who behave in such a way to undermine the stability of the group. And we also know, of course, that in human societies this is the case. And in many instances, people have reflected on the underlying acceptability of when to punish. And in consequence, the criminal law has developed in many, many places, in small groups, in large groups, in whole nations. And the criminal law evolves over time to try to become more and more acceptable to punish only when it's appropriate. And that usually means that the person must have actually performed the action. He must have actually known what he was doing and known that it was wrong, and he must have been in control. And normally philosophers and others associate this idea of being in control and hence responsible for your action. They associate that with free will. So for example, if someone is not in control because he was pushed, let us say, then the criminal law usually would take that into account and say, well, the person didn't really do it himself. He wasn't really in control. But philosophers have kind of backed up from that and asked the question, well, are we ever really in control? If, as we think, that choices and decisions are the outcome of the physical brain and how it works, that probably seems to mean that our decisions and choices are caused by antecedent conditions of the brain. And so people have said, well, can you ever be considered really in control if your brain is a causal machine? So that kind of is the current take on the question of free will. Now, some philosophers and some scientists have taken the view that free will cannot exist because the brain is essentially a causal machine. That in a certain very deep sense, we should not ever hold anybody responsible, or at least we're never truly justified in holding someone responsible. Even if they were awake, they knew what they were doing and they intended to do it. Because if you think about that intention, the philosophers argue, the intention was caused by antecedent events. My own view is a little different. I want to say, well, what view of free will should we have? I mean, what would allow for saying that someone was responsible? Would it be better if the intention was totally uncaused? It just sort of sprang into being? Would that make the action free? And most philosophers recognize that no, that would not either. In my own sort of thinking about this issue, I've been very influenced by what we know scientifically through experiments about the nature of self-control. And we do know that all mammals have the capacity for varying degrees of self-control. So if you're a fox and you're hunting a rabbit, you better exercise self-control. You have to wait for the right moment. You have to creep up silently. And we know that the young foxes don't have good self-control because the young fox will just tear after the rabbit. The rabbit flees. He gets nothing. He learns through that experience. The basal ganglia, the reward structures, learn not to do that. And so through time, the young fox pup learns to behave like its mom, and it's cautious and it's careful and it waits until the appropriate time. The fox pup also learns self-control in other conditions, and here again it will imitate the mother. It will learn to lie very, very, very quietly when there is a big predator like a bear about. And again, this engages, or this changes and tunes up the basal ganglia, the reward structures in this really quite ancient part of the brain. So self-control is something that we know that all mammals have. And acquiring self-control or developing self-control is itself a causal process. And there seem to also be genetic differences between animals that can exercise self-control and animals that can't. So let me give you an example, and this is from Trevor Robbins' lab in Cambridge. So he wanted to study self-control, and he was interested in having a good experimental paradigm for that. Now, we normally think, as he pointed out, that self-control involves the capacity to defer gratification, like the baby fox waiting. It also involves the capacity to cancel an action. So that, for example, if you're about to go into a parking space and a child runs into that space, you will put on the brakes and stop. That's canceling an action. I can cancel an action as I move towards my coffee cup. It also involves the suppression of certain antisocial or unsocial impulses. So Trevor Robbins and his lab wanted to figure out a way to measure self-control, deferring gratification in rats. So first of all, what they did was they put a food tower in the rat's space. And the rat comes into his space. He learns very quickly that if he nose pokes, he gets a pellet, which he wants because he's hungry. Now, after a while, you put in a second tower. And in the second, oh, he's interested, he explores, he nose pokes, he gets 4 pellets. Better. And he learns then to do that. So where's the deferring of gratification? So you can introduce a delay between when the rat nose pokes and when the 4 pellets come. Can the rat wait, or will it not be able to defer gratification and go for the single pellet? And what we find is that some rats can wait, and then wait, and wait, and other rats cannot. It's like they sort of, give up and go to the other one. And the circuitry underlying self-control has consequently been quite well studied in the rodent. And so we know that the circuitry involves structures in the very front of the brain, but also these reward and reinforcement learning structures in the basal ganglia. The precise nature of that relationship is not understood, because we know that self-control can also be affected by motivation. If I'm very frightened, I may not defer gratification, or if I'm very tired, I may behave in a slightly different way, and so forth. So how the brain negotiates self-control and motivation and so on is not really well understood. So one way to think about the nature of the free will problem has to do, in fact, with understanding the causality that underlies self-control. Now, we know that self-control can be undermined not just by things like extreme hunger and extreme exhaustion. It can be undermined by drugs. So a huge effort around the world has gone into understanding the neurobiology of addiction. And the main addictive chemicals that people have studied involve cocaine, heroin, nicotine, and alcohol. And what is known now is that, it's going to be a very complex story, and I think only part of the story is in place, but we know that there are very specific physical changes in the reward system in the basal ganglia. And it sometimes looks as though those very specific changes actually are quite permanent. But we know, for example, that if someone is addicted to nicotine, that in certain very specific kinds of experiments, for example, when they evaluate what they could have done in a task, unrelated to smoking, but where they could have done something in a task instead of something else, they're poor at making those evaluations. And so understanding addiction is very, very closely related to understanding the nature of self-control. And here's another important part of what has come into focus in understanding addiction. And that is that initially someone will get a hedonic response. That is, you get high or you feel great from binge taking the substance, let's say cocaine. But always after the hedonic response, there's a bit of a dip, normally. But after someone takes cocaine again and again, what we see is that hedonic response is not very high. The anhedonic response is quite low, deep, and it's protracted in time. Well, what causes the anhedonic response that follows? And the answer seems to be stress hormones go way up. Now, you know what it's like to feel anxious, to feel stressed. It's uncomfortable. So what does the addict do when they're in this anhedonic trough that goes on for a long time? They take more, which gives them an even lower hedonic response and an even longer dip into the anhedonic response. And this profile, I think, has helped us really understand sort of the conscious experience of addicts, but it's also really helped us to understand the nature of addiction itself. Why there is this anhedonic response remains a puzzle, but that does seem to be just how it is. It's how it is in rats, how it is in monkeys, and it seems to be also how it is in humans. Now, there are other domains where we wonder about self-control, and one of them, of course, has to do with adolescence. Because we know that adolescents, especially in groups, tend to be big risk takers. There's something about being together in a group and being an adolescent that motivates risk taking. So there are scientists who are now looking at this both behaviorally and at a deeper level in the nature of the brain. And one of them is Sarah Jane Blakemore in England. One of the things that she reports is that mice, they have a very, very fast development relative to humans, as you know. But there are 1 or 2 days where they are adolescents before they actually become adults. So people have tested their risk-taking behavior during that adolescent period. So this is mice. And one of the things that they find is that adolescent mice will run on an elevated maze, which normally adult and baby rats do not like to do. They fear falling off. But adolescent rats, especially in the company of others, are quite happy to run an elevated maze. They will take a risk. It's also been found that adolescent mice will binge drink alcohol if given the opportunity, especially when there are others around. So I think what these results suggest, but it's only a suggestion, is that there is something about risk-taking in the adolescent brain that we really need to understand. And I think in the present context of the political world that we live in, it also motivates us to want to ask why young men in particular, but not only young men, are willing to take these really extraordinary risks to join a motorcycle gang or to join ISIS or to go off with their mates and beat up other soccer fans, which we know that they do. So that, I think, is a very important development in neurobiological research, is understanding the respects in which the adolescent brain, with regard to certain features of self-control, are a little different. And I should add here that, of course, adolescents can be very highly controlled in one domain and somewhat less controlled in another domain. And I don't think we really understand the neurobiology of those differences and what makes for those differences. I think the problem of free will is a very interesting problem, especially as it arises in the context of the developing child, because we want a child to have self-control that's adequate to his adult life. And we want people to have self-control so that they don't get into all kinds of trouble later in life. But we also have to understand it in the context of the criminal law. I don't myself foresee major changes in the criminal law as a result of this, but of course these are very early days, and it's possible that there will be ways of addressing certain issues that come before the criminal court through discoveries in biology. But I haven't myself seen anything yet that really motivates those kinds of changes.